Let's have a look at question 5 now. So the standard deviation for the ideal number of children according to men is larger than the standard deviation for the ideal number of children according to women. Okay, so we have the data sample for men and we have it for women from the lowest to the highest. Now, first of all, let's understand what's a standard deviation. What's the intuition of it? The standard deviation is the square root of the variance. So we call the standard deviation as sigma, and the variance is gonna be sigma squared. So sigma squared, this one is gonna be the square root of it. What's the intuition of the variance? What do we try to show with it? We're trying to show how far does every observation in the sample deviate from the average of that sample. Meaning that if we wanna write this a bit more mathematically, it's gonna be this sum. This is gonna be this sum of all the differences between every observation in that sample. So xi stays for every observation, from, right, the difference from the average in that sample, and we take it to the power of 2. Now, the intuition of the power of 2, why do we take it to the power of 2? Is because sometimes when we add these differences, we will have, for instance, a difference of -2, and at one point, we will have a difference of +2. You see, these differences are gonna cancel out, but that's not accurate to show the variation, because we actually have a variation. It's just the variation happens to be 2 units to the left or 2 units to the right, and because we don't want to cancel out that effect, we're taking it to the power of 2, because now that difference is gonna have an actual result. Like -2 to the power of 2 is gonna be 4. It's gonna be an actual you know, an actual positive number, so that -2 with +2 is not gonna cancel out. We'll actually have 4 + 4, and that's gonna give us 8. So the whole intuition is this: we don't want to get rid of some differences, because that's not gonna give us an accurate estimate of that variation. So to prevent that, we take it to the power of 2. That's the highlight. Now, with that said, let's be practical. Let's solve it. What do we need first? We need the averages. We need the averages in both samples. So let's calculate the averages in each sample. In the first one, we have the average of the sample for men is going to be what? The sum of all the observations. So 0 + 0 + 0 + 2 + 4 + 4. 2 + 3/4, that's 2 + 12, which is 14, divided by the number of observations, which are 7 observations. Just to count one more time: 1, 2, 3, 4, 5, 6, 7. 14 divided by 7 is equal to 2. We got 1. Let's calculate also the average for the women, sample. So 0 + 5 × 2 + 4. 5 × 2 is 10, + 4 is 14. 14 divided by the number of observation is 7. That's equal to 2. The same average. Okay, now let's calculate the variance, right? The first step is the variance, and then we take square root of it. Let's do it, the variance for the men. So let's go over here. Actually, we need to go below to keep in mind all the, you know, all the numbers. So we go over here below like that. We will have something. We'll have something like this. The variance, right? The variance is gonna be the sum of all the differences to the power of 2. So let's start with the differences. The difference between the first observation of 0 from the average, 0, and the average is 2. So that's going to be 0 - 2 to the power of 2. 0 - 2 to the power of 2 plus the second one. We have another observation of 0. By the way, you know, let's be a bit more practical here. We'll have 3 differences like that: 0, 0, 0. So 0 - 2 to the power of 2 is going to happen 3 times. Let's just multiply to the power of 3, you know, to save up some time. Otherwise, it's getting too long, the video. Plus the difference between 2 and the average of 2. So that's going to be 2 - 2 to the power of 2. We got that. And then we have the difference between 4 and 2 3 times. 4 - 2. So that's going to be 4 - 2 to the power of 2. And we have that 3 times, so we'll multiply that by 3. Yes? Now, let's do the math. What do we have here? 0 - 2, that's -2 to the power of 2 is going to be 4. So this whole thing is going to be 4 times 3 is equal to 12. Plus, we go to the next one, we have 2 - 2 is equal to 0 to the power of 2, that's just 0. Plus 4 - 2, that's equal to 2 to the power of 2 is equal to 4. 4 times 3 is equal to 12 as well. So 12 plus 12 is equal to 24. That's just the variance for the male, right? For the man. Let's write it over here. Let's write it over here. This is the variance for the man, equal to 24. The standard deviation of it is going to be square root of 24. So the standard deviation of it is going to be equal to square root of 24, which is going to be equal to 2 square root of 6. Right? If we write it, this could be the same as 2 square root of 6. Okay, we leave it like that in this video. In the next one, we replicate the same method to find out the variance and the standard deviation for women and compare them.